Okay, this is 1.7. We're talking about operations, exploring operations with functions. So operations, of course, are addition, subtraction. So we're looking at, really what we're looking at is kind of adding two functions together. What happens? Okay, so we're going to look at kind of what happens with that graphically, as well as what happens with that algebraically. Okay, so it says explore the properties of the sum, difference, and product of two functions. Can you read from back there, Tony? A popular
coffee house sells iced cappuccino for $4 and hot cappuccino for $3. The manager would like to predict the relationship between the outside temperature and the total daily revenue for each type of cappuccino sold. The manager discovers that every 1 degree Celsius increase in temperature leads to an increase in the sales of cold drinks by 3 cups per day, and a decrease in the sales of hot drinks by 5 cups per day.
Okay. The function f at x equals 3x plus 10 can be used to model the number of iced cappuccinos sold, and then this function minus x plus 200 can be used to model the number of hot cappuccinos sold. So it makes sense, right? As the temperature is going to go up, they're obviously going to sell more cold coffees, and as the temperature also goes up, they're going to sell less hot coffees. Okay, and as it gets colder, they're going to sell more hot coffees. So they have this kind of inverse relationship happening. And so if they give us the price, which they do, they tell us iced cappuccinos are 4, and they tell us hot cappuccinos are 3, then we can figure out kind of the ideal temperature to make the most money. That's the idea behind this question, right? So it says in both functions, x represents the daily average outside temperature. So we can also see the scale is the same. Sorry, the y-axis scale is different. So important to note that. See how it's going up here by 30, and here it's going up by 25. So that's probably would have rather graphed them with the same scale to get a kind of more accurate view of what's happening. But in any event, x represents the daily outside temperature. In the first function, f at x represents the daily average number of iced cappuccinos sold. So these ones are iced cappuccinos here, and these ones are hot cappuccinos over here. Second function represents the daily number of hot cappuccinos sold. So how does the temperature affect the daily revenue from cappuccinos sold? So we need to have this piece of information and this piece of information to know what the daily revenue is going to be. So the first part says make a table of values for each of the function with the temperature in intervals of 5, from 0 to 40. So our table of values here, we're going to have our temperature.
Sir, it's
Off the screen, thanks. Okay, and then we would graph iced, then we'd also have the same table, but we'd have our temperature versus hot cappuccinos sold, and we're going to put it 0 to 40. And I think I have a table that's done. Yeah. So this is pretty easy, right? So this is just saving a lot of time if you want to write these down. All we're doing here to create this table is we're substituting in the value of x here into each function. So if we substitute in 0 here, we get 10. If we substitute in 5, 3 times 5 is 15, plus 10 is 25. Okay, so we can easily create that table of values both for f at x and g at x. X is, of course, our temperature, and this is cold, and this is hot. Any questions on how this table is created? Alright, it's the first one. And you can always, if you don't finish copying this, you can always freeze the frame on YouTube and get that down. B, what does h at x equal, what does h at x equal f at x plus g at x represent? Who can tell me that? Sorry? I'm going to ask you one more time. So what does this function represent if it's f at x plus g at x? Yeah, Elijah.
The amount of sales of hot coffees and the amount of sales of ice caps.
Yeah, so it actually represents the total amount of cappuccinos sold, and I'm going to put in brackets hot plus cold. Okay, it's the total amount of cappuccinos sold, hot and cold, when the temperature is x degrees. That's what g at x would represent, h at x, sorry. And the reason why is because we're adding the cold amount plus the hot amount, so makes sense. Any questions? We're gonna get there. We're almost there, yeah. But to answer your question in short, how would I graph it? I would use the same value of x, so the value, let's say 10, and just add the y values, and that would be my new point, but not add the x values. Does that make sense? So in this table here, okay, well, it's right here anyways, h at x, it's just going to be these two values added, okay, but the same value of x. You guys see that? So f at x and g at x, you add them and you get h at x. Okay, so you just add them up and then you graph it. I think that's 2 questions away. It says simplify next. It says simplify up here. G at x. So we have 3x plus 10 plus negative 5x plus 20. So we can do the math here. We're going to get 3 minus 5. So this h at x is going to be equal to negative 2x and then 10 and 220. Sorry, 200. So 210. Right? So what we're learning then is we can combine functions by adding their y values, and we can actually algebraically combine them just using normal math, right? We can just add up those functions very simply. Next it says make a table of values for the function in part C. So here's our new function. Now we go ahead and make that same table. So there's our temperature, or our x, and then here's our h at x. And we plug in the values 0, 5, 10, 15 all the way, and then just sub these values in here. 0 is going to be 210, 5 is going to be 200, etc. And we get this table, which is right here, D. Any questions how I've done that? Next, what does h at x, they should have used I here, in my opinion, because it's a different function. So I would have made that I, but anyways, they're calling it h at x, equal when f at x minus g at x represents. So let's look back here. So if I take this function and I minus this function, what does it represent? Luigi, what do you think?
For E?
Yeah, E.
It would give you the total number of hot drinks sold.
No, that's G at X. That's there.
Oh, so cold drinks. This is
No.
the total of minus.
Say it again?
So it's the total of cold drinks sold because it's
No, the total cold drinks sold is F at X. The number of cold drinks sold. Yeah, Remo.
would be the difference with the profit of whichever.
Oh, not the profit yet. It's just we're just dealing with the Y value. So we're actually just dealing with the difference. You're right. So it's the difference of cold versus hot sold. Okay, because we're taking the cold value and we're subtracting the hot, how many we sell in hot. So they write how many more iced cappuccinos were sold than hot cappuccinos when the temperature is X degrees. This is probably more accurate, difference of cold versus hot, because we can't just assume that they're going to sell more cold, right? And in fact, later on, when the temperature is quite cold, they don't sell more cold. So the difference of cold versus hot sold is more accurate, because it's not necessarily always more. Any questions with that one? Luigi, you're good?
Yeah.
Okay. F says simplify. So again, it's asking us now to do the algebra here. Do the algebra in subtracting those two. So h at x, we got 3x minus 5x, so that's plus 5x, is going to give us 8x, and then 10 minus 200 is negative 190. And then it tells us to make a table of values. Okay, so the exact same way. There's our table of values. Did I mess that up? They have, well, looks like they messed it up. 180. Yeah, they made a mistake here. Should be negative 190. Yeah, you can see that that mistake is reflected right there. This should have been negative 190. You guys know who does these answers?
Nelson.
University students?
University students. Yeah, good, right?
It's like the 12th mistake. I never knew that. This is one
Yeah, university students are paid, I wouldn't say minimum wage, but very low wage to write the answers. The authors just do the questions, believe it or not. All right.
you don't care. No, it's exactly.
Okay, so we made a table of values. Any questions on how that was made? We're just subbing in values again for x and then solving for h at x. How do the domains how do the values with the values in each table you made in part A? How do the values compare with the values of each table you made in part A? All right, so we looked at this. Here's our table in part A. Okay, how do they compare? Well, the first table, we're just adding them. 210, 25 plus 175 is 200. And the second table, we're subtracting them. 200, 10 minus 200, 25 minus 175. Okay, so they compare exactly how we would expect them to compare. Right? How do the domains compare? So how does this domain compare with this domain and with this domain? What is the domain, right? It's the x values. X values, that's our domain. How do they compare? Okay, they're the same. I wouldn't say X are all real numbers because it would be tough to sell like 2.7564 cappuccinos. Unless you had like a very accurate scale and you were pouring out the liquid at like, you know. But it would probably just be whole numbers, right? It definitely wouldn't be negative because you wouldn't have negative cappuccinos sold.
So now you would.
Sorry?
Oh,
Oh, sorry, you're right. Yeah.
It would be up to negative 27.
Yeah, but the range wouldn't be.
Yeah.
The range would be whole numbers. Yeah.
yeah, that makes sense too. The size of the
All right, we're on H now. So over here, it says, what does R at X equal 4 times F at X plus 3 times G at X represent? David, what do you think? H. There's a big hint with that capital R. Yeah, good. It's the revenue. Excellent. And the reason why we know also is because the cold ones cost $4 from the original question, right here. Okay, and the hot ones are $3, so we know this R here is our revenue. Next it says simplify 4 times 3x plus 10 plus 3 times negative 5x plus 200. So this is going to be 12x plus 40 minus 15x plus 600, which is equal to negative 3x plus 640. Next says make a table of values. Same thing with the temperatures in the same range. How do the values compare with the values of each table you made in part A? How do the domains compare? Alright, so again we're going to do temperature, Rx, 0, 5, 10, 15. Sub this in to this equation, we'll get 640. Sub this in, negative 15, so we get 25. That is J. There's our table. Okay, so this table here is this table here.
So this is 605.
640, 625, 610. Any questions with how the table is made? It says, how do the values compare with the values in each table? The values follow this pattern. So, all 3 domains are the same. We can see that here and here. And then the values follow the pattern of the same algebraic we would expect. Okay, so this value 640 is going to be 4 times this value plus 3 times this value. Right? 3 times this is 600, 4 times this is 40, so 640. So the values are what we would expect. Finally, last question. How does temperature affect the daily revenue from cappuccinos sold? So the way we would determine that is we're going to look at the daily revenue. This is our daily revenue. And this is our temperature. So as the temperature goes up, what happens to our revenue? It goes down, yeah. So even though the cold cappuccinos cost more, they still sell so much more coffee or regular cappuccinos during the winter that as it gets hotter, people just buy less coffee in general. So there's less people buying cold cappuccinos than there are people buying hot cappuccinos. That's why the revenue goes down as it gets hotter. Okay? And you might have predicted that just by looking at the initial graphs. See how high they get? They get all the way up to 190 with hot cappuccinos sold, and they don't ever get close to that. Even when it's 50 degrees out, they're still only at 150. Okay? Alright, finally we'll look at these reflecting questions quick since we have time. Explain how the sum of the function g at x would be different if both f at x and g at x were increasing. Well, if these were both increasing, then the sum would be increasing even more, right? I think that's self-explanatory because you're summing them, you're just adding them up. If both functions were increasing, the sum would be increasing. If both functions were decreasing, the sum would be decreasing. Makes sense. Okay? What does the function k at x represent? So this is the difference now between the hot and cold. So how many more hot cappuccinos did they sell than cold cappuccino? Is the graph identical to the graph f at x? No, it would be the opposite, right? It's not the same, it's the opposite. Okay? Determine the function f at x times g at x. Does this function have any meaning in the context of the daily revenue from cappuccinos sold? So the number of cold sold times the number of hot sold. Would that have any meaning?
No.
No, that has no meaning. Explain how the table of values of this function is related to the table of values of part A. Well, you would just multiply those results that were made in A. Okay? You would just take these results and multiply them. 2,000 wouldn't make any have any sense whatsoever. Finally, if you are given the graphs of two functions, explain how you can create a graph that represents the sum of two functions. So this is a good one. A, the sum of two functions. If I'm given two graphs, so I have this graph here, and I have this graph here, same graph. How could I add these two together? They're going to equal, if I added this is y equals x, and this is y equals x. If I wanted to add these two together, it would be y equals x plus x. So it would be 2x. So my slope goes to 2. Okay? So your x values stay the same, but your y values double. So what was once 1, 1, 1, now becomes 1, 2. Okay? The difference between two functions. So if I had now this graph minus this graph, y equals x, and this is y equals 2x, I would be left with y equals x again. Okay?
Are they asking for the difference between 2x and x, or x or the?
I'm just making those up.
Oh, okay.
It could be any graphs. It could be, 2x squared plus 10, and then the y2 could be x squared minus 5, and then y3 equals y2 minus y1 would be 2x squared minus 5 minus 2x squared plus 10 minus 5. Okay? Could be anything. Okay, you just do the math, and then you would graph this separately. You can graph it by making a table of values, or you can graph this by recognizing that there's a vertical stretch of 3, it's reflected in the x-axis, and it's vertically translated 15 units down. Okay? The difference, and finally the product of two functions. So exact same thing, so just the algebra applies. Alright, so the product of these two graphs would be x times x, which would be x squared. Yep. Alright, any questions? Okay.